So with fair use of Leonard Skinner there, this project is called Simple Man. It's a project to do a DIY guitar effect MIDI controller. So the project is to firstly create a test bed just to show how it works without actually building a particular controller unit for a purpose with 6 switches and some other hardware. I'll go into that in the next slide. So once we've created the test bed unit itself, it's going to mount the hardware and connect to a controller unit board. In this case, we're using an Arduino Nano board. Review the software that drives that board, which is an Arduino sketch code, and demonstrate the test bed MIDI control of a guitar effect unit. In this case, it's a Chase Bliss Automaton Preamp Mark II, which I have on my pedal board. And after that, we'll use the lessons learned to build and install a practical MIDI controller based on the lessons learned. Just realised I've repeated that text, but there it is. That will be something that will actually be used live, and there's a reason for doing that. So the question is, why bother with this? So I've got my reasons. There may be reasons you might like to do this, but the reason I've done this is I am another typo, semi-professional guitarist and MIDI controller hobbyist for many years. Semi-professional is probably a stretch of the imagination to a degree, but I get paid for playing guitar in a band, so that's not amateur. So I started doing this because I wanted to have MIDI control of my effect units, and this is going back probably more than 10 years. They were very expensive, and I could have spent the money. I just resented having to spend that much money on a controller unit. I thought there was a better way, and there was. My first experience was with a unit called a highly liquid MIDI CPU. It did the job. It was programmed in hexadecimal, and I'm not. I've got a very basic understanding of macros and using basic programming. This certainly stretched me beyond all reason. So I'm saying it's as bad as it sounds, but I got it to work, and my lack of skills, I was able to overcome them and make it work. But it was fairly limited. So with the advent of Arduino for a hobbyist board, that changed everything. That was many years later. And it's cheaper, easier to use, and the Arduino sketch code is using a C+ basic-like syntax in its coding. So Arduino sort of was the next big leap forward as far as my experience goes. So I had fun and invented controllers to do more than was realistic or practical for using on a pedal board. I had LCD readouts. I had Bluetooth integration to my phone. I had some remote control aspects to it, and all sorts of elaborate things that just because I can, but they turned out to can't really use them live because there's too much going on. I'm too busy playing and doing what limited vocals I do. Also, and over time, MIDI controllers became less expensive themselves, so the DIY need, motivation decreased to a degree. These days, you can get some really great units. I mean, they would have cost an unbelievable amount of money years ago, but now they're very affordable. But I've got 3 reasons to bother making a DIY controller. The first thing is I'm old, well, much older, and I need to wear comfortable footwear to play live. And that means I'm wearing shoes that have a wide sole on them, and the spacing of a lot of these switch units just make them impractical for me to do that. And I'm not willing. I mean, I can get away with wearing less comfortable shoes, but I don't want to. I need to wear more comfortable shoes. Also, I want to simplify and remove other bank functions, for example, and reduce issues playing live. you know, again, with you accidentally hitting two switches at once, I accidentally switched banks. And some of these units, one I've got has up to 100 presets, 100 banks. Um, I only want one bank. I want the switch to do one thing and have enough space for me to put my fat foot on it. So that's these are actually genuine needs for me at least, um, and I enjoy doing it. The last reason is why not? Because I can. I enjoy doing it. I do want to share the knowledge. It may be that a lot of people look at this and say, "So what? You know, there's nothing. You're way behind on this. This has all been done before." But if you're like me and you don't really have a strong skill set or experience and background in these things, um, it can be really satisfying to be able to use electronics and do these things yourself. Another little typo there with the DIY experience. So I've just got another couple of slides to go over what exactly is going to be built. This is a picture of an Arduino board. It's a nano board that we'll be using for this project. And you can see the arrangement of it is it has some control pins that are labeled here, for example, D3, D4, a few other pins, and on both sides of it. And it has I think there's a mini USB connector for uploading files. You can even power up through that. A few indicating LEDs. So that's the general layout of an Arduino board. This is not a genuine Arduino. This is Key Studio, and there can be some compatibility problems with cheaper Arduino boards. Also, when you're doing the sketch file, sometimes the pin number that's referred to in the software, the sketch file, so pin number D2, for example, in one board may have a pin number of 5, in another board it may have a pin number of 4. So these are things you just need to work out later. So there are a few variables, but it's all workable. So the basic layout of the pin out here and how it connects to some other hardware units is for this. We're going to be using this pin here. I know it's upside down. VN is the voltage in. Going to be supplying it with 9 volts positive in there. That's the standard power supply for guitar units. So this unit can take 9 volts. I think it takes up to 12 volts. And there's the negative of that power supply coming in. We're going to connect the pins using A0 through to A5. We're going to connect these pins to the negative terminal of some LEDs. So this is my attempt to draw an LED. And the positive pin of the LED will be going to a 5 volt supply coming out of the board itself. The 5 volt supply will be reduced by this resistor to that positive terminal. So you see one side of it has a common power connection for positive voltage. The other side of it has a individual negative connection to the Arduino board for its individual LED indicating control. The resistors are all 220 ohm or designated 220R used on these LEDs, and I'll get to this piece of hardware, the MIDI DIN connector, also used in the MIDI DIN connector. The other side of the connection is there'll be 6 switches. So this for the test bed, we're going to have up to 6 switches, and each of these switches similarly has a common connection, in this case to the ground there, common connection, and the other leg of the switch, they're just 2-pole momentary switches. So that's important. Remember, momentary switches, not latching switches, is generally how these things work. And the other leg is connected to the individual control terminal. So as highlighted here, there's also an additional switch here that's connected to the reset pin. Here you can't see it, but there's actually a button that resets the unit. There are good reasons to do that, so I set it up as a reset pin here. The other connection for this project is the output of the MIDI signal goes out through a 5-pin DIN connector, and this is the rear view of the DIN connector, 5-pin DIN connector. So you can see there are 2 pins we're using. One is at about 11 o'clock and the other one's about 2 o'clock, 1 o'clock, whatever you want to call it. There's pin 2 and pin 4. So pin 2 is connected to this terminal called TX, TX1 or TX, and pin 4 is connected to the positive voltage supply coming from this pin on the nano controller board, and it's also connected through this 220 ohm resistor into pin 4. That's the extent of the connections that need to be made for this project. Just be careful you get 220 ohm, not 220k, which 2k is a very common measure of the kind of resistors you use in these projects, and that was a mistake I made early on trying to get these things to work, and eventually figured out it's 220 ohm, not 220k. So the rest of the project is about putting this hardware together. Just having a closer look at the nano board, you can see it's got, this is the other way around now. So if you're good at reading upside down, these are the D2, so digital, D is digital, are the pins we're going to describe as input pins. We go to D through to, what is it, 1, 2, 3, 4, 5, 6 to D7. And the output pins for the LEDs will go from A0 to A5. You can use, A stands for analog, but they can be used for digital functions, except A6 and A7 can't be used. So you can see that the nano can do so much, but you are limited. In the more practical project that I'm going to implement, I'm controlling 8 switches and 8 LEDs. That's about the limit of what for this kind of use. That's about the limit of what a Arduino Nano could be. You have to go to an Arduino Uno that has more. There's the next size up that has more outputs, but 8's all I need for what I want to do. I could squeeze 9 out of it by using D13, but they say not to use D13 because it's somehow linked to the onboard indicating LED that you use for test purposes. I don't know, but that's the layout of the board. So the next step is to go through the practical hardware side of things.
So the next step, or the first step, is to start building the test bed. It's going to be fairly simple. So it's going to be 3 sections, or more than 3 sections, but basic is there'll be 2 wooden ends like this and a piece of aluminium section inserted into it. There'll be cuts made into that wooden end for the, I think it's about 2 mil, maybe 1 mil section size to go in there, and that'll be about halfway down or some way into the wooden sections. The idea being that this aluminium is where the components can be mounted, but the whole unit can be turned upside down for soldering and to get to the part. So one section will be on this end, so I'll have, say, all the LEDs here. The other section will be at this end, and I'll have all the switches there, and in between I can mount the controlling board, the Arduino Nano board, which I think I'm going to be using, and maybe some other components, and you can just turn it around and access everything easily. The size of this is based on my layout here. So I'm going to have the 6 red switches, mini switches there, are going to be for the controlling switches, the control terminal switches. This switch here is going to be a reset switch for the Arduino board, and this will be a power switch. The power supply, I'm going to use a 9-volt battery. There's a battery clip there that I'll mount somewhere in this unit here, and other hardware that needs to be mounted. I will mount a power supply socket, standard sort of stuff you use on um, for power for pedal boards, probably center negative, as they all are. And there is a 5-pin DIN MIDI connector, which I can mount on the board as well. I'll use the 5-pin connector um, just for now. You can see that there are some pedals and other equipment going away from the 5-pin connector into 3.5mm TRS type connectors or similar. In reality, if you look at the configuration here and you look at the pin at 12 o'clock, that's the positive, that's the earth, and the pins either side of that at say 11 o'clock and 1 o'clock carry the signal. I can't remember which one has voltage and which one doesn't, but you only really need those two at 11 and 1 o'clock to carry the signal. The earth is just for shielding, and those at 9 and 3 o'clock are, in most cases of MIDI connection, redundant. Some use them for phantom power, some use them to do both an input and output in one cable, but the convention is that you only need the 3 pins. And in short runs on pedal boards, you probably mostly don't even need the 12 o'clock pin for the earth shield. There's not going to be a long cable run likely to have any interference. You can get away with just using 2 wires. And you'll see later in this project what those 2 wires are. So the next step from here is to cut this out. I think it'll be, I'm going to build it to be 30 centimeters wide. That seems to fit based on this ruler. So using metric measurements, which is the measurement that rational people use, not the measurements that someone ate some mushrooms in the Middle Ages. I don't know. I'm old enough to remember those old measurements and realize more than people who can't remember how crazy they are. So 30 mils, 30 centimeters is the measurement. So that's my little rant on the metric system. And from here, it's just a matter, I think, of taking a best guess as to what these. Welcome back again. It's been a little while since I did my first video where I said I was going to make a test bed, which I have done. So let me just go over this thing. It's just a couple of pieces of wood, pine, and some aluminium sections that I've mounted here. So you can see they've just got a single screw holding them in, and I've put a little rebate in this slot with a piece of felt, and they're just pushed in, holds it quite firm to stop it racking from side to side, and also I can take it apart easily if I need to. So the whole point of this thing is to be able to mount all the test hardware and also get easy access front and back. And what I mean by access is accessing the underside of all the connections. So the bits of hardware I've installed are these, in these AM sections, I've cut holes to mount the switches, push button switches for testing. There are, these are for the LEDs. You can see the bezels for the LEDs. I already put a couple in. This is to mount the 5-pin DIN connector. Here I've got all my bits of hardware laid out here on this bit of foam. On the other side, I've got holes to put the switches. These are just little momentary push button switches I'm going to use for testing. There's 6 of them, so this is for 6 switches as a test and I have a black one, number 7, for which is the reset switch, being the reset switch for the controller unit, which is an Arduino Nano. Um, I've mounted that in the middle on a piece of wood and can get access to the connection pins on the other side. I tried to find some standoffs and screws to mount this thing, but if you see, if this thing will focus, the holes to mount it are so small, I really struggle to find the hardware to do that. So I've just put a small cable tie through it to hold it onto the board. The board is just thick enough to allow access to the pins for the type of connectors, which are DuPont style connectors like this. And I've got some um, DuPont connectors in gangs of 6 like this that will make it easy to organize the connections when we get to that point. So the other side here is for the switches, and also I've got a wiring harness for the power supply. So there's a 9-volt battery clip which I'm going to use for the test. So the wiring harness is a 9-volt battery, which then goes to the standard kind of 9-volt that's power jack, that's plug socket, I should say, that's used for a guitar effects. So this is wired center negative, and I think I can't remember how I wired this, but I've wired this so that it's a switching jack. Let me just get that in focus. It's a switching jack, and I've wired it such that when the you can see the two power, where when a power supply is plugged in, it switches off the battery, and when there's no power supply connected, plugged in, the battery is turned on. So I'm going to, and I have a switch for the power as well. So I'm going to mount that in these holes here. So there's a hole for the switch and a hole for the jack, and the battery is just going to clip into that clip there. So that's the test bed. So I didn't bother filming a lot of that. It's so basic. You can see I've just got these aluminium sections here, um, about 4 mil by 2.5, and a couple of other aluminium sections that I riveted in place just to be able to mount the Arduino Nano board. So I think the next step is just to go through putting the hardware in place. So